Hello and welcome to the hundred and something 60th maybe virtual jug session, probably more like about 70-ish. And yeah, welcome to a new speaker. In fact, I don't think you've been on the virtual jug before. Sven Rupertt, how are you doing, Sven?
No, fine, thanks.
Awesome. And whereabouts are you calling in from today, Sven?
Munich,
From Munich.
just from Germany.
And
Yes.
are you in the office or at home?
No, no, I'm out of the last meeting, and finally I can be useful.
Ah, excellent. Yeah, meetings get in the way of all that stuff, don't they? And joining us, as usual, as our regular, Oleg. How are you doing, Oleg?
Pretty good. Hi, people. Really excited.
And Rebel Labs has been doing some awesome work with some cheat sheets. Tell us about what's coming up and what's been happening.
Yeah, so last year, in the end of last year, we started doing those cheat sheets, basically one A4 page that you can print and that contains information in a very concise form about like various topics. So we did Java 8 best practices. We did a Git cheat sheet that went viral, and we are producing right now, as we speak, producing the Docker cheat sheet, which is gonna go live tomorrow, hopefully, if nothing goes wrong. And I'm really excited about those. It's really nice form to digest information.
Awesome. Yeah, they seem to have been doing really, really well. I'm just going to try and share my screen and see if this works. Because for some reason I decided just before this call to add another monitor, so hopefully this will work. Okay, so let's click that, and now click this and click that. So hopefully you can see what's coming up today. This is we're going to be talking about dependency injection frameworks, some hidden pearls. And our speaker, as I mentioned, is Sven Rupertt, 2Ps, 1T, and you can follow Sven on Twitter at Sven Rupertt. It's going to be a good session. I think DI is something which, although has been around for a while, is something which is critically important in pretty much every web application, really, and beyond web applications. So I think it's very, very good to get a good understanding. And Sven's a perfect person to tell us about this. The virtual jug is sponsored by Zero Turnaround, and all sessions will appear on Rebel Labs, and you can grab some write-ups. And also speaker interviews, which we do after every single session. If you wanted to hear more about Zero Turnaround, you can, of course, download a JRebel or XRebel trial, and you can make class reloading and lightweight Java profiling a reality. So today, you can access the session interactively on IRC. If you go to Freenode channel #virtual jug, you can ask questions live to Sven, and I'll relay those questions live into the Hangout. You can, of course, share the group and session. We're well over 5,500 people. I think I may have just made that up. No, we are over 5,500 people now. So the group is growing massively. So please do be a part of that and share the session around your friends and colleagues. Any feedback around the session or indeed the group, please, best way to do it is either ping the virtual jug on Twitter or myself. The handles are both there. So without further ado, let's jump into the session and talk about DI frameworks. So over to you, Sven.
Okay. So, okay, I will start sharing the screen.
Perfect. And just while you're sharing that screen, I'll mention to people that if they in the bottom right-hand corner, I think it's the bottom right-hand corner of the video, there's a little cog, a little settings cog. If you click on that, from that list, you'll be able to select your quality, and just select the highest quality. I think 720p is typically the highest, and that way you'll be able to see Sven's screen the clearest.
Okay. So let's share screen. And we will start soon. So, can you see it?
Yep. We see the Hangout in a minute. There we go. Perfect.
Okay. DI framework, some hidden pearls. Well, as mentioned before, my name is Sven, and I'm very happy that I could earn my money since 1996 with Java, and I'm working for an Italian company called Reply. We are around 5,000 people, and I'm head of R&D. So I have enough time to play with a lot of stuff, and well, since all those years, I was working for a lot of different projects, different companies and all this. This means I mostly got projects that are old. So a few 100,000, a few million lines of codes, and mostly what use from different developers, and they all played around with this. And mostly at one point we started to divide all this stuff. I have to say it's one of the first times I'm using this tool. So if you see too many animations, I really try to reduce it. Well, as I told, it's the first time I'm using this one. So this means during the time we were asking or playing around with dividing to some things, we started to think how I could divide bigger projects into smaller portions. So the targets we want to reach is more or less that we want to divide a system into modules, and we want to decouple contract and implementations. This is, well, easy to say, but mostly we want to decrease complexity too. And all this stuff, we started to decide what is enough decoupled. So let's say we have one of these very easy methods. Execute. You will get back a list of data and what's going on in that. So I have an import statement because I'm using this interface. This is, well, this is clear. Everybody told me at the university, if you want to couple something, use an interface. But what's going on internally? Internally, I'm writing maybe something like this. I want to create a result list, and I have an explicit decision for this array list. So quite often I see this implementation, and then I ask my colleagues, why are you using array lists? And the answers are different. But the most thing is, I had done one experiment. So I used an IDE that you can use, that you will get as open source one, and I changed the IDE in a way that the first thing that it will recommend for a list will be a linked list. And I gave this to my colleagues, and they were using it, and after this I could see that they are all using linked list, not array list anymore. So here is the biggest question, why I've done this decision, and was it right? So I have this import, and then if I'm not using something like trim to size, maybe this implementation is not the right one I want to use. So why and what kind of questions I have to ask myself, and these are the questions a dependency injection framework will give you an answer through, or you have to help this dependency injection framework to give the right answer to you. The main thing here with this easy piece of code, I want to get array list. Well, let's say what kind of questions I will get now, and what kind of questions the DI framework would give an answer through. The first one is, what will be the right implementation? If I could get an answer through this, then it's okay. The next question would be something like, what's the right time to decide it? And after this question immediately, I have the next one. This is, what's the right frequency to decide if this is the right time, or if this is the right implementation? So the three questions, a dependency injection can help you to give an answer at the right time. Okay, this means we will start with what's the right implementation. The right implementation, if you want to use Java, I could use, for example, a factory. And then I had something like an import statement for the list and a method like that, create a list. Maybe I want to use it in this way, but what I created now is the same as before, because I have a dedicated method that I'm using, so the decision is in the same static way as it was before. The next thing, I have a different implementations, maybe my list, this list, whatever list. And so I have with this factory, if I'm doing it in this way, one part where every single implementation will bound through. Maybe later I'm starting to create some generic methods, but inside the generic method I have mostly the same static decision. So did I reach any goal here? So I have this directly named methods, I have this static implementation or this static decision here, and if I'm comparing now both implementations I had before, I have mostly a list on both sides, an array list here on the old implementation, and here I have the create array list, for example, with the factory method and the import statement of the factory method. And factory method itself, it's a huge bunch of decisions or static combinations of implementations. The next question I try to think about is what's the right time to decide. And mostly, if you are checking dependency injection frameworks, you are getting scopes like this one. But if you're checking here, all these scopes are mostly technical scopes, singleton or application scope or a session scope or a request scope. But do you really need only technical scopes? Maybe it would be very interesting to have some business scopes or user-defined scopes. So what's the right scope? And the next thing would be what's the right thing you can do to make these decisions, or what the dependency injection frameworks will give you as a tooling to decide and what's the right thing. Let's say we have an interface service with a method do work, and we have one implementation for this and one business module. So the first thing I want to think about, if there's a dependency injection framework, what kind of or what ways the dependency injection framework could give you to connect both instances. Here I'm using the constructor. So this means I have here only possibility to use this special constructor to connect both instances together. The next one would be I could use a dedicated set method to combine both. And the last one a dependency injection could do mostly is using reflection. So these are the three ways dependency injection framework could use to combine both instances. But sometimes it's a very interesting question. If you decide what kind of dependency injection you're using, then mostly you will get this decision done for you. So the dependency injection will say, okay, I'm using constructor the constructor method, or I'm using the reflection way, or whatever. And at this lifecycle you have, for example, think about you have a JavaFX program, and then JavaFX itself will have a lifecycle. And CDI, or dependency injection framework, will have a lifecycle too. How you could combine both lifecycles. For example, with JavaFX, you have the problem, if you have an instance and there's an add inject inside, or you have an fxml file, and then this lifecycle from JavaFX will create the instance. So what's the leading lifecycle? The CDI one, because we have an add inject and the rest is following, or do we have the XML file that's loaded and will start an instantiation? So fxml will be the leading lifecycle. So both mean you have to combine lifecycles in a way. Here, if you have, for example, the constructor lifecycle, this means you have a timestamp 1, creating the instance of the service. You have the timestamp 2, create the instance of the business module, and then you can invoke the method. But if you have, for example, the set method, you could have something like create the instance of business module, create the instance of the service, or a way around, and then setting the service, and then you can invoke the method. So it's a little bit different lifecycle. And the next one, with reflection, is nearly the same. So you are creating the business module. If you created the business module, you could create the instance, and then you can set the instance and invoke the method. This means The decision, if you're using the constructor, the setter or reflection, will give you the possibility to make decisions at different times, and maybe the order in which you can think about what's the right application. Okay. Every framework will have a strategy, how to resolve what's the right implementation, and how to create and set the instance and manage the timeline. Let's start with Weld. Weld is a reference implementation. And what could you do compared to Java SE? I'm using only the SE dependency injection part of Weld, only to make the examples easier. For example, with Weld, you have something like post, construct, and pre-destroy. So you have some information about the life cycle, and you can jump through. You have the dependency injection, which qualifies an alternative to have the decision what's the right implementation. We will have a short view to this. Maybe you have something like scopes, or you have interceptors, decorators, stereotypes if you want to combine qualifiers. You have events, you have portable extensions. But what's part of a dependency injection framework? Here it's a context dependency injection framework, but what would be the minimum you're using or you need to compare dependency injection frameworks? For example, qualifiers and alternatives mostly used because you must have the possibility to decide what's the right implementation. Some with life cycles you need to say, okay, now it's the right time for the init method because all instances are set. Scopes, well, some will have scopes, some will have no scopes. And the biggest question I always get is, do you need events? Are events part of the dependency injection framework? Well, some of them will have some, but I say events are not really the minimum you need for a dependency injection framework. So we'll focus on the three first one. That means injection with qualifying alternatives if you have an interface and you have one implementation. So the add inject somewhere, if you're using the interface, because you want to decouple, is quite easy. The decision is clear. One implementation, one interface. Everything is fine. If someone in your team will give you second implementation, this could be an inner anonymous class, for example, then you will have immediately a problem because the dependency injection framework, Weld, will give you something like this, a Weld exception. The good thing with this exception is that with this method you can ask Google quite fast and you will get some answers. So to make now the decision here, you can add a qualifier to the next implementation and then everything is fine because now you have two namespaces, a default namespace for easy decisions and some extended namespace. In this example, is a prod. So to get the other implementation, you have an add inject add prod service prod. The problem here is that both decisions are very static. So during the time you're writing the code, you have to make the decision or you have to lead to some implementation. And the biggest question here is this is the right time to decide it? And I would say maybe it's better if you can do this decision later. So those must fit here together. The next thing is that if you have an interface and you say, I want to use a producer, you have somewhere a method that you can annotate with producers and with some namespace like prod2 with a qualifier you're writing by yourself. Here is producer. And then you can directly have the decision, please make an add inject and use this producer. If you're using Weld and you know more ways, you could use the following pattern. You're jumping through a producer, and inside the producer, you can decide what could be right implementation at runtime, and then delegate to other producers or to other implementations. But this will lead you to some more complex implementations. Okay, so the combination would be with this. But here you have an annotation inside your code that is a technical annotation, and want to get rid of this. Okay, so next one would be, If you want to have something like an alternative, same as here, you have to annotate, for example, something, then you can use at inject without any annotation, but you're shifting all this stuff to the beans XML so that you're activating there the right implementation. So CDI is one of these dependency injection frameworks that force you to make all decisions or the decisions during startup from the container. And then everything must be right. You can't change so many things anymore. And then this must be the right decision for the whole runtime. Okay, so let's say if you had an add inject service here with this interface, you can use something in a programmatically way. You can say, please give me the instance of the container and select the same interface and decide now the right time with a .get. So both are the same. Both will give you the same implementation, but with the second line, you can decide it programmatically later what's the right time to get this one. Another thing you could do is you can get an instance. This means you're getting a virtual proxy so that you can later ask what's going on. And the same you could do programmatically, that you can say, instance, lovely container, please give me an instance from the selected interface service. And if you want to decide that you have a different implementation, you could use this annotation literal to decide, now use this one that is annotated with the qualifier dev. And you can say, give me this with this dedicated producer. So these are more or less all the ways you could use to, or you go through to get an implementation. But there's one other way. You could do it in a manual way. For example, if you have a leading last, and this will get the instance you're using, and then you want to inject some things, you could do it programmatically. You can use this inside your constructor to say, now it's the right time after creation to inject everything into my own instance. This means this was a product programmatically way. You have here a service, so that means you have only the class and you have no instance. But if the instance was created from somewhere else, then you can write something like activate CDI, and then you can do everything manually. To get the class, then it's a bit of technical stuff, depends on the Weld container. This means here, get the bean manager, creates annotation type, creates the injection target, creational context. So you have to do all the things by yourself, but you could do it. Then inject everything with this context through this instance. But I saw this implemented and I forgot a little bit. Please, you go through the full life cycle. And if you have done this, you can use this method or this way to trigger the injection stuff by yourself if you have the instance created from some other frameworks. Okay. So the next one I want to show you will use a different way. This is an open source framework, Boon. You can go through GitHub to get it. And this one you can use quite easily. For example, you say add the dependency division in your pom.xml. Please use this one. And if you want to use standard inject annotations, you have to add this. Otherwise, it's using the own inject annotations. So the bootstrapping is quite easy. But how to define what's the right implementation and how to check what's going on there. If you're checking a little bit the implementation, you will get a lot of things you know from other dependency injection frameworks. But the most important thing here is that you have no scopes. So this is a framework that you use if you don't want to get all these session scopes or request scopes and all this stuff, so you have to manage it by yourself. But Boon is not using annotation processing and no bytecode manipulation. For example, Weld is using this one, but the creator of this framework didn't want to use this one. So the only thing he could use now is he's using reflection. This will give you the possibility to do more things at runtime. Okay, let's play with a hello world. This dependency injection will give you the normal post construction, so the life cycle, and the add inject, and it's easily working with sub injection. Service will inject, a service will inject the next one, and the post construct. If you're testing different dependency injection frameworks, make sure that you know in which order the construct will be invoked. First for the sub-service and then for the service, or the way around. Okay, so if you're checking what's going here, you will get some information that dependency injection will work with static methods, and it will create something like modules. And this is more or less the way how to define is the right implementation here. This module concept is used by a lot of dependency injection frameworks. But what does it mean? The dependency injection will give you the possibility to create a module, and then you will give, for example, the service. Then you have to get the input from this module. And in this case, what's going on with the subservice? Here, the subservice will be not injected because you forgot to give the subservice class through this module. So you really have to make sure that the whole object graph is created by yourself. And if you're doing this one, then you can create the module, and then you will get the instance. Everything is fine. So this means you can create runtime this module, so you can create the amount of classes that are available for the decision what's the right implementation, but you have to do everything yourself. But you can do it at runtime, and you can do it with, or other way around. You can create as many modules you want, like only quite small object graphs. But you have to make sure everything done by yourself. If you're playing a little bit with this, I started to see you can define this not only programmatically, you can define it in modules, in classes, so you don't have to implement an interface or something like this. You only have to use naming conventions, and this means that you have a provide service or provide subservice. So he's going through naming conventions, and then this instance of module you can use to create a module and then to our dependency framework for an instance of service. That's the other way around. So you can define the whole object graph in a static way, and you can use producer. I played a little bit around with this, and this provide looks like that there's a naming convention. What really is going on with this? So playing around with this, the first thing is it's not refactoring safe. So if you're changing service, name provide service will not change. So make sure that everything will be changed by yourself. And this is something that's normally not very nice in bigger projects. At runtime, you could use add module and remove module. So this is a dependency injection framework that's more dynamic because you can modify the object graph at runtime, but be careful. This means I started with the service module and played a little bit around. It says, okay, please use the provide service A method. And then I started with, provide service B and provide service C. You could see at the right side that I'm using system.println only to identify which factory method is used later during my tests. But if I can have more modules, I started with the same. What's going on if I'm using module B, provide service A, provide service B, and provide service C? And so I created both modules and started to play around with this. Look here, the provide service A and the provide service A in the second module. And you will see provide service AA will be say, okay, this module was used, or this factory method was used, and it's the same here. Okay, writing it a little bit compact. Start with creating a context and try to get an instance, and we'll get provide service AB. This was not what I expected. So I expected something like AA or AC, but definitely not AB. So I played a little bit around and says, okay, take one at module B and check what's going on here. Context get service. So is the original service be changed? And I'm getting service AB. So nothing changed. If I'm using the new context, I'm getting the same, provide service AB. And then I started with adding both modules at the same time, but with first A, then B. I'm creating the context. The instance will provide service AB. So the behavior is not what I expected. So I tried to figure out what's going on here. And this was during a project that was using this one. So they started with a hello world, tried to identify what's going on with dependency graph and all this stuff. And later they found out in the graph they have different modules and different providers, and then the behavior was different. So the next I done was I thought with module B, create a context, and I got immediately service BB. So again, the version, but from the module this time. Then I added the module A, and I got the same behavior. I got the first one, provide service BB. So I had a symmetric prob here. And the same was add one service BB. And the next one, I created both together with module B and module A. And what a surprise, I got provide service BB. So I immediately wanted to figure out what's going on here. And it turned out that internally, I have only these two methods that I use. So all the other provide things are not used. So let's see, I started with module A, I started with module B, I created B1 and B2. And now I checked what's going on with the dynamic part, add and remove module. So I added module A, I added module B1, A2, B2, and I'm getting service provider A. That means the first one, the leading one. Then I removed module A1 and got service BB. Okay, so it's now switching. And this I've done over the whole chain, and I got AB again. Then I removed the next one, and I got BB. And then I thought, okay, remove the last one, try to get something, and I'm getting null. So what I wanted to show here is, if you have the dependency injection framework, play around with the definition how to create object graphs, and if you have dynamic parts, really play around what's going on with this. So if this is merging the object graph, or if this is only chain object graphs, and what's going on if you're removing and adding this stuff. Here, I wanted to see what was here the problem. So digging through the source code will show you the only thing he's checking at this dependency injection framework is starts with provide. So the rest of the name does nothing. If you're checking here, a class get declared methods, immediately you will find out that this one is not sorted. So every get declared method will give you a different order of this of method. This can be the problem to get always the AB or BB version of the method, the factory method. So the next one is everything was stored in a concurrent hash map, and it turned out, yes, this will be stored with the string keys. And to test this, while this is, you can only use a concurrent hash map and say, okay, but provide A, B, D, B, or whatever you want to have. You can change this order. And if you're printing it out, the last one is always a B version. Which means if this will change, so if the implementation will change internally the concurrent hash map through something else, you could have a completely different behavior of your system. To make sure that this is not happening in a big project, try to identify these problems. So, but with the dependency injection frameworks, sometimes they have something like prototypes. So they want to give you the possibility to create a prototype in a long way, and then you have not this initialization anymore in a way that you have to combine everything by yourself. So they will give you the possibility to have a deep copy. What does it do with a deep copy? I think everybody played around with this, and here the most thing is there's a demo class, there's an interface, there's an implementation of this, and here I'm connecting both together by hand, and then try to figure out if you really get different instances, and it turned out, okay, you can register a prototype at runtime, so you can change the prototype, and then you can create the context and get a new instance, and you will get something that's different. That's a nice thing. The next thing, if you have prototype, check if the full lifecycle is done. So I changed this to at inject a sub, and it turned out that here you have to register all this stuff by your hand, and you can use here, same with get an instance, register this full managed instance as a prototype, not a self-created one, and then you can create the other stuff again, and it turns out that everything's running well. If you have is using reflection, or if dependency injection frameworks are using reflection, then make sure that the new Java 8 classes are working properly. For example, some implementations, and Boon do, will have problems with local date time. So if you're registering a prototype here and say, okay, please create everything, then it will give you an exception. And if you're going through source code, you see that it's not using reflection in the right way. So the combination of inheritance and implementing interfaces is here leading to an exception. So make sure that with this, everything is going well. So the next thing is, if you want to have something like the qualifier we had with Weld, some similar things on different dependency injection too. So here is a way to register with a string with a name, and then you can use it in a way. But as you can see here, this is definitely not reflecting safe. So another interesting thing with dependency injection frameworks are make sure that you test with interface and class. It turns out that you could use only classes and no interfaces anymore. So make sure that you really test it, otherwise later in your project could be a little bit funny. Okay. You could create everything at runtime. For example, create at runtime and compile it, or if you're writing it by yourself, and do the same here. So with the static information at named, some value inside, you can define the same way of what's the right implementation. So this is more or less doing the same as it was in Weld. And some dependency injection framework will give you something with invoke and then a completely decryptive way of invoke methods, but it's only a way that Boon is doing, but I wouldn't recommend this one. There's overhead and it's not refactoring. Okay, so this was a framework that's using more or less reflection with all the plus and minus with reflection. So you can change a lot of things in runtime. You are limited to things that you can identify with reflection. And the main thing is that this will be very dynamic, but then there are some other things you can't use it with Android, or if you're using M, could have problems. So with Dagger, you have another thing. Here they're using annotation processing. So everything you have to decide, or you have to give this dependency injection framework in a way that during the annotation processing part, everything could be generated. Here this is done as in the other one. So you have something like a business module, and you have to define the object modules or the graphs itself. That means you have a main service, you have a main implementation, and then you have a huge bunch of technical things to write. For example, create an instance, but this is not managed. You have to annotate this one with provide, There's only to mark it, and then you have to write all the module information. And the really interesting thing here is that you have to define what could be a target too. So if I'm not saying here main.class, then if I want to have an add inject in main.class, this is not really working. So all the things are done during the annotation processing time, so everything will be created, compiled, everything will be fast at runtime, but you can't change it really. So, and you have to make sure if you want to have a managed instance, for example, because main service implementation itself we're using an add inject, you have to do it in a way like Weld, so that you have the param from the method to get a managed instance. This is quite a lot of work you have to do. And so to give an answer through the other questions, what's the right implementation, or decide between different implementation, you have the same with provides and name A and name B. So everything is in the static semantics too. And to have it a little bit more dynamic, you could use something like give me both versions, implementation A and B, and then decide. But the most or the thing you have to do is that everything you have to do by yourself. So there's no help from the dependency injection framework to make decisions. So this is completely done by yourself. And the next thing is, for sure, you create a instance, but you can change it in a way that here again you will have something like proxy use. And the biggest question is what kind of virtual proxies you have. Here you can say, okay, give me a lazy service, and you have an instance, and some others will give you some other class or interface use. And then you're only using the virtual proxy, and after you have your decision, you say, get me the instance. If you want to have bigger projects, check what's the right way to combine different object graphs to a huge object graph, and this could lead to a lot of work. For example, here you have to do everything manually. You have to make sure that everything is wired in the right way, and this is quite a lot source code you have to write. Okay, so if you're using this one, you can include different modules, and you have to make sure that everything will be connected by yourself. The good thing here is, if you're using, for example, a named B, something that's not defined somewhere, the compile will break. And this is a good thing with annotation processing based dependency injection frameworks. If something is not fitting together, most you can identify it in the code generation part, and then you can break with the right, with the right information. So next one. Interesting here is, again, create instances of object graphs, but you can create a lot of them. And if you're using this object graph to manage an instance, there's no protection against using this on the same instance twice. So in your architecture, you have to make sure that this could be, that it's not possible that an instance could run 2 times against the object graph to be initialized. This is really hard to debug to find out what's going on. But there's no support from the framework to protect you against this one. Okay, and singletons here are only singletons per object graph instance. So if you have something like singletons, check what is really the meaning of the singleton. Okay, the good thing is, if you have annotation processing, and with Dagger you will get something like this, you will get the whole object graph in a file, and then you can analyze and visualize this one to check if everything is right, or if you have cycles, or what's going on here. Okay, so Google thought this is too much work, and they decided to have Dagger 2. Dagger 2 is a new version. Both are, I think, actually developed, but Dagger 2 is reduced one, so removed all the runtime reflection. Really, Dagger 1 has a little bit of this, and the module complexity, and introduced interface for module composition. So they shifted everything to a different way of description. Okay, so Dagger 2 is only if you want to have to migrate and you have an old one. The object graph is removed, and instead of this you will get builder methods or builder classes, and the migration itself is quite easy. So the model migration removes only all the attributes, then it's clear. So changing here, this is done quite easily. And the next one is if you have components, then you're creating an interface with this factory methods or the declaration of factory methods, and annotate this one that it's a component, and the factory method itself will be generated. So this means the Dagger 1 will say create an object graph and then get an instance, and the next one is that you say, okay, I have a builder, I create this module, build something, and then you are invoking the factor. That's the biggest difference you have to do if you're changing your project from Dagger 1 to Dagger 2, but I think this is a good decision if you are changing this one. So the next one will be something that is built not, so the first one was with bytecode manipulation. The Boon is using reflection. This Dagger was using annotation processing, and HK2 is completely started from scratch for the Java SE environment. It was used in Glassfish and has some really nice features. So it's only see what's if it could fit to you, because you have if you have a standard SE thing that you. Oh, I switched the slide too fast. So you have something like events, okay, if you need it or not, but there are very special things. The custom injection resolution, this means you can customize the way how an inject will be done. You have run level and all this stuff, so you can customize it a little bit more without using different frameworks. So how's it working? The bootstrap is quite minimal. If you say I want to use it, you can add this to your POM. And then you can add, for example, the run level support with a string dependency, but you have to create this HK2 locator. It's a source locator file, but if you don't want to do it by yourself, you can use this metadata generator, and everything will be during the clean compile processes for you. So this is the only thing you have to add to your POM, and it can start. The definition here is a little bit more restricted. So you have to use an interface, and this must be annotated with contract, and the corresponding implementation must be annotated with service. Otherwise, the HK2 is not working. So this really must be together. This was a little bit, but maybe this is working for you fine. So the next thing is you can say, okay, at inject some service that's working, or you can provider, that's a virtual proxy. So everything you will get here too. You can say, I want to have an inject with a concrete implementation. This is too. And one interesting thing here is you could ask the Bean container, please give me something I can iterate over to get all implementation for something for an interface. This could be some interesting feature. Custom injection resolver, you can define quite easily. Say, okay, I have an alternate inject, and then you're using this one for your injection, and you have to implement the injection resolver. With this, you can use the full HK2 functionality, but can customize the at inject part by yourself. And you can dynamic runtime. Okay. But I played a little bit around and asked myself, maybe do it in a much more easy ways. All the frameworks are forcing you to write a huge bunch of binding code, and I want to minimize this. This is boring. I want to customizing it, so the code base must be small to understand everything. And model validating, I found with all dependency injection frameworks are mostly technical model validations. But maybe it would be nice to have something like, oh, in my database are 3 customers, so it needs 3 implementations, or whatever. It's only an ID. A clear lifecycle and a very short lifecycle, so that it makes easy to combine it with other frameworks. So clear error messages, okay, easy debugging, so please give me a way so that I can set everywhere breakpoints and see what's going on there. A dynamic context, all the dependency injection frameworks, even CDI, force me to go through the startup from the container to make sure every decision is done, but think about something like, oh, I have two implementations of an algorithm. One is using a lot of memory and is very, very fast. And the other implementation is using definitely less memory, but is slower. The usage of the memory inside your server is increasing. At a certain point, you have to make the decision, no more users or no more instance of this algorithm, or switching the implementation. So it would be nice if the dependency injection framework would give you the possibility to write rules like, oh, if the usage of memory is so high, please, with the next add inject, use the implementation that is slower but using less memory. So you have a self or a dynamic reconfiguration in your system. If you're using dependency injection, think about mocking, because you want to be as near as possible as the production code. And sometimes you could use this in your team to lead to functional aspects without saying it. Okay, easy plugin development. So what was the main target to decide? If you have an add inject, then you have an interface and you have your implementation, and you would say there's no binary code necessary. So the most dependency injection frameworks are doing this one because there's an easy way of decision. But the next thing is, if you have a second implementation, how to make this decision and make it in a way that it could be done dynamically and without of writing code. Here, how to decide, and this is one of the main questions for a dependency injection framework. If you're using it turns out that if you're using something like a class resolver that's only activated or is only searched for if you have more than one implementation, what gives you the possibility, for example, in production code to use an interface with one implementation, and during your test you're writing or implementing this interface class resolver, and this will lead your mock instance. But at runtime you have nothing. But if you have an implementation class and you have a producer, the same is here. If you have two producers, the only way is that you have this producer resolver, and then you can use different producers. It turns out that this chain of question, or this chain could solve the most or all questions we had. And it's really fast, so you can jump at every point to make new decisions, and you can actively change what's inside your class path. And the dependency injection framework could deal with this new information. The most thing I'm missing at different dependency injection frameworks is they will give you the possibility to inject a lazy or a virtual proxy, but no dependency injection framework will give you the possibility to customize this proxy. For example, if using proxies, why not give me a metrics proxy or start logging? Or maybe you can say, okay, it's a virtual proxy, but if you're using a virtual proxy, it could be a static generated one or a dynamic one or whatever. So what kind of proxy and what's the technology to create? And what is, for example, the concurrency level or the scope or whatever. So here, if you can customize all this one, then you have a good way of define things only once, or make sure that this technical part is put through the dependency injection or behind the dependency injection framework inside your code. So I'm using the way that from top to bottom the instance creation will be done, and at runtime I want to create, add or remove business rules and have the possibility to say, okay, lovely dependency injection framework, please activate the module or check the active module. So validate at different times because you know there was a change. quite often use this question about scopes, per request, per JVM singleton, per session, or whatever. Do you need really scopes, and what's the right scope? So mostly you will have to find an answer through a business scope, a wizard scope, or whatever, and how to define scopes. You can define scopes with Weld, you can define scopes with other dependency injection frameworks, so to make sure to analyze how much work it will be to define our own scopes and what's the right space to define. Mostly the scopes are only defined before you start the container. But what's the right place to define scopes? Check, mostly I see something like this. You have net inject and then something like a hard decision for a scope with an interface. And then it will lead you to an implementation. But it could be in a way that you say, okay, the implementation or the interface will get an attribute with the scope. It's a static too. Or it could be at the implementation. So there's a completely different behavior. So if you say, okay, the implementation, only this implementation will be a singleton, or all injects with this interface is a singleton, or I define at this point I will get a singleton. But mostly these are decisions that are fixed. So I want to create all this in this code. So it makes sense to find another way to describe this one. So think about the way that you could go through the dependency injection framework and make sure if you could define this at runtime at the Bean container to say, okay, I want to have every inject for this interface. And if you have done the decision for this implementation, make sure that this implementation will be a pooled one or a singleton or per request. Activating scopes at runtime is something that could help you to make a much more dynamic system. And then, yeah, inside business code, only add the inject service, and then that's it. So you can switch scopes between implementations. Okay, so the biggest question at the end is that we have to think about if you're writing something for desktop, web server, microservice, IoT, or whatever, what could be the right implementation for you? For example, if you had the desktop one, mostly you need no scopes like session or request or something like this, so you can use everything with reflection and annotation processing. Mostly you have a huge amount of dependency injection frameworks you can use. For web server, mostly you're using something like Spring or Weld because you have all these technical scopes inside. Microservice, well, it's your decision. And at IoT, it turned out that's mostly to reduce the amount of electricity or the amount of power you're using, that you don't want to use reflection or bytecode manipulation. You want to use mostly generated code. So you have mostly a very static version file. For example, Dagger, Dagger 2 is not bad, and play a little bit around with this. Okay, so we have all this together. These different kinds of dependency injection frameworks. We spoke about a little bit what is a way to define what's the right implementation with annotations or with creating object graphs, with dynamic created object graphs, or maybe with conventions, so that you can say, hey, I have something there, so this fits together. We had used something with bytecode manipulation that's done at runtime. We had Boon that's worked mostly with reflection and dynamic at runtime. And we had Dagger and Dagger 2 that's using annotation processing, so everything will be done during the clean compiling. We have K2 that will get some service, so I think it's a nice thing if you're working for SE environments because you have something like run levels or different customized injection points. And I created this open source project for you so that you can play around with this Rupertt PM dynamic dependency injection. This is an approach to make decisions at runtime, and yeah, we are using it in production. So if you want to check it or try it, this dependency injection framework is with mutation. We have a test coverage of 90% with mutation testing, and it's maybe interesting to see in which way you could make decisions. So use it as a base for your own implementation, or only to play around with this, or using it in production. If you have questions, come to me and ask. I really would love to get your feedback on this. And you can contact me on Twitter or check at GitHub what's going on. And I'm done. Thanks.
Awesome, thank you very much, Sven. Got a question in IRC at the moment. Give me 1 second. Here we go. Got a question in IRC. Let me find it. I think it was actually from you, wasn't it? Oleg. Almost called you Olaf then. Much frozen.
Not sure what question you're talking about, but yeah, I had some.
So we got one question. Let me find it. Okay, here we go. Here we go. Come on. Sorry, my mouse is dying.
Well, I can actually ask that directly, maybe.
Yeah.
So, Sven, when we're discussing Boon, so somewhere in the beginning of the session, mostly,
Yes.
and you said that you will have to do everything yourself, right? With Boon, because it uses the reflection, so you'll have to specify classes and modules and assign them. So my question was, obviously that was maybe your example to illustrate the basics, but if I just need to create everything myself, isn't it easier to just create those classes with constructors and then inject them by assigning them into the fields? So,
well, yeah, okay. The always the right answer is it depends. I got this Boon DI. I saw that it's if you have not really huge one, but mid-sized projects, and you're not running inside an EE container, or you're not using the Spring ecosystem. So in this. You have a very flexible way of building modules and all this, and if you find a way, for example, to create by yourself a few of these things, you have the possibility to have really everything with reflection dynamically. If this fits to you, I'm not sure, but it doesn't force you to use constructor injection, so this structure methods. And you can use easy way of programming with new instance and all this stuff. And the lifecycle itself is not so hard bounded through this. But if you say you like more this constructor dependency injection way, well, this is only Boon DI is only an example. You can check the implementation. You have the full object graph by yourself. It's not so many things you have to define. You only have to be very disciplined, so that's not happening. What happened with these two modules I created with this different behavior of factory methods. That's the only thing. But otherwise, it's a small, nice framework. It's running well. But, yeah, some strange behavior if you're using it wrong. So this is only for small and mid-sized project. Maybe more for small projects.
Okay, awesome. So we have no other questions right now, but I'll just talk about what's coming up next on the VJug. So if anyone has any further questions, please do put them directly into IRC. While we do that, I'll just ping. Here we go. This is Sven's contact information again. I think it was on your final slide as well. So do follow Sven and ask any other follow-up questions if you're watching this as the replay directly to @Sven Rupertt, 2 P's 1 T. And thanks very, very much to Sven. I'll check the questions in a sec. Just before we continue, this is our next session. In fact, we do have one tomorrow, which is a book reading club. It's actually the third session out of 3 on beginning Java EE7 with Antonio Goncalves. So Roberto and Ivan will be running that, so do make sure you're checking that out tomorrow. It's a slightly earlier time than normal, which is at 3:50. So do check that out if you're interested. You can RSVP directly on the meetup site. The next normal, regular virtual jug session without books is from Monica Beckwith at mon_Beck. I'll definitely be asking her why she's got an underscore in her Twitter name. But yeah, we're going to be talking about GC tuning confessions of a performance engineer, and this is Monica, who has a lot of experience with JVMs, the internals of JVMs and GC logs and things like that. So that's going to be a great session as well. So do go to meetup.com to RSVP to that if you're interested. So let me just check if there's any other questions for Sven. And of course we'll be doing our no questions at the minute, but we'll be doing our interview session with you, Sven, straight after this, if that's good with you, and we'll post that directly up onto Rebel Labs. Awesome. Yep. So thanks very much, Sven, for your time and your session, and thank you everyone online for watching along, and anyone on the replay who's watching a little bit later. And we'll see you next time. Thanks very much, guys. See you later.
Thank you, Sven.
Thanks. Bye.